Hello everyone, welcome you all to AI Ki Pathshala. And today, first of all, we are going to discuss about the one recursion question that we have already discussed in the previous class. But today we are going to discuss the same problem in an alternative way. We will code the same problem in a different way and understand the second approach of doing the same problem. So first approach, we already are aware of it. So second approach, we will do it. So let me share you my screen first. And those of you who are watching my recorded session, I appeal to all of you, whatever session I am conducting, it's absolutely free of cost. You can join me in my live session. Every day I used to conduct this session at 10 p.m. IST. So you can go to the description section of the video and join my Telegram group link. There I give all my updates about my live classes. So, and I'm going to take the session of Python, statistics, machine learning, deep learning, and lot more things. Just come and join me there. So let me share you my screen first. So here goes. Okay. So are you able to see my screen?
Yes.
Fine. So let me share you this thing. This is Jupyter notebook. So what was my last question? Let me just recall you my last question that we have already discussed. The question was, find the index of last occurrence of X in a given list. This is the question. Find the X of last occurrence of
But your voice is slightly on the lower side. The last time it was very clear.
Okay.
Crystal clear.
Let me see. Is it fine now?
Yeah, it's fine.
Is it fine now?
Yeah, it's fine.
Fine. Find the index of last occurrence of X in a given list. This was my question. And in the last approach that we have, the first approach that we have discussed in this question, that we can take any list, and then what we are going to do, we will make a copy of the list. Every time the size of the list will keep on decreasing till we reach the base case. Now, here what we will do, we will do the same question with the help of SI, that is the starting index value. So we will approach this, we will deal with the same question with the help of starting index. So let's write the condition to solve this question. First, I'm going to write a program, and thereafter I will take one example, and I will explain you how this entire code is working. So let me write you a code first. Def last index B, and three things I need to pass here: A, comma X, comma SI. A is the list, X is the occurrence of the value whose last index I need to find, and SI is my starting index. So what is L here? L is equal to len of A. And what is my base case here? My base case is here, if SI, my starting index, is equal to L. That is my base case. I will explain you this. If that is my base case, then I will return -1. First, let me write the code. Smaller output, smaller list, output is equal to last index B, And let me pass same thing here. Let me pass a here, comma x here, and si plus 1. Every time I am increasing my starting index by plus 1. If smaller list output is not equal to -1, if smaller list output is not equal to -1, return smaller list output. List output. Else if a of si is equal to x, return si, thereafter otherwise else return -1. So this is the code actually. Let me check this code. Let's run this code. Take one value, a is equal to, let's take 1, 4, 5, 4, 8. This is my a. X is equal to, let's take 4 and take print last index b to be a comma x comma 0. Let's run it. So I get C. Now let's understand how this entire code is actually working. This is the main thing, is that to understand the code. See, this is first understand this part of code, then we will understand this part of code, then we will understand this part of code. So 3 part of the code is there. So we will understand one by one. First thing here is that whatever list I am defining here, last time what we were doing, we were decreasing the list size of the list by 1. And every time what we are doing, we are making a copy of the list. Every time we were making a copy of the list. But in this approach, we will not do this thing. What we are going to do, we will not make a copy of the list. We will use the same list, but we are changing the index, starting index position, SI. SI refers to starting index position we are changing here. So first thing comes the base case. So what is the base case? Let's say there is a list. Let's take this list only 1, 4, 5, 4, 8. Let's take this list 1, 4, 5, 4, 8. This is my list. This is my 0 index, first index, second index, third index, and fourth index. So what is the length of the list? L is equal to len of A. What is the len of A? What is len of A?
5.
5. If len of A is 5, so it is asking SI is equal to I. SI is equal to L. That means what is my SI? Is equal to 5. When my SI will be 5, starting index. Let's say in this case, I have started from 0th index. So first, the value of my SI was initially this.
Yes.
Then it will increase to this. SI value will get, starting index value will get to 1. Then it becomes 2, 3, 4. When after 4, starting index value will become 5. This is 5. But this time what is happening? I am coming out of my I have already completed when I have reached Si is equal to 5. When I have reached Si is equal to 5, I have already completed my list. I have already touched all the elements in the list and I have came out of my list actually. So when Si is equal to L, it means this is my length. When Si become equal to L, that means what it means? I have already traversed all the elements of the my list and I've reached at the end.
Yes.
I've covered this index value, this index, and I've reached at the end of the list. All values I have checked. So it means my base case is, let's say my starting index is this. If I am starting from this index, 0th index, so what it is going to check? It is going to check if length is equal to, if Si starting index is equal to n. When my starting index will reach the end, so return -1. I am returning -1. -1 means I have not found anything. That means I have not, till here I have not found anything. So I have reached here and I have not found anything. So I have returned -1. So this base case, this means these things. If I have reached here at the end and I have not found anything, let's return -1. Whom you should return -1? To the previous function call.
Right.
You are returning -1 to previous function call. Now, see the next thing. What is my next thing here?
So means that when the starting index is 5, that means we have reached the end, that is empty, that is no element is there.
Yes, no
Empty
element. We have crossed all the elements and I have reached the end. And I have, since I have not provided any condition here to check, so it is not checking anything, just it is reaching at the end and it is returning -1. It means that now the things will become much more clear when we see the coming things. See here, if till Si is not equal to L, I am returning -1. And if Si is not equal to if Si is not equal to L, what will happen? If this condition is not true, what will happen? It is coming here. It is coming here. I am providing the condition here. Now, what is this condition? Let's say if Si is not equal to N. In that case, what I shall do?
It will go to smaller output.
Smaller list output. Here, what is this? This is a function call. But the difference between this and this function call is simply the difference in the value of the starting index.
SI.
Whatever SI value I have given here, I have increased my SI value to +1. Rest thing is remained same. That is the value of A, and X has remained same. Only SI value has increased by +1.
Right.
So this is also a function call. So it will call the next, it will recursively call and increase the starting index value by again by 1, again by 1, again by 1, again by 1, again by 1. It will keep on increasing. And till how much value it will increase? Till we reach this point, till Si become L. Because when Si will become N, it is going to return -1. Is it fine for you? So let's understand this in this way. Let me write it in a different way so that it will be understandable. So let's first write this thing as, let's take this thing as this is my 1, 4, 5, 4, and 8. This is my list.
Yes.
Now, this is my starting index. This is my index value 0, 1, 2, 3, 4. This is the value of X. And this is my starting index. Let's understand this. Now, what will happen? So, let's understand this. What is going to happen now? First thing is that let's check. This is my list. This is the value of, this is called A. What is my X? X is equal to 4. And what is my SI, starting index? I am taking SI as 0. So I am starting from this index. I am starting from this index. 0 index. Is till here things are clear?
Yes.
Now, when I have taken SI is equal to 0, what it will check? It will check SI is if SI is equal to N, what I get?
No.
False. False. So when I get false, what will happen? It will come here. My control will come here. Now what it is going to check? Smaller list output. What is my smaller list output? It is a recursive call. Last index B, A X SI plus 1. So what is the value of X here? Value of X is 4.
Yes.
And what is the starting index? Let me write in.
0 plus 1, 1.
So, sorry. No. What I am asking, when I have started, my X value was 4. Because I have to find the index value of last occurrence of 4. So X value was 4, na? My here, see.
Yes.
X is 4. And what is my starting index when I just started?
0.
Starting index is 0. Fine. Now, here what is happening? My starting, this remains same, A remains same, X will remain same. Only my starting index value is changing.
1.
So this time I have started from this index from 0 position. And now what is happening? I am starting from this index. Let's say 1, 4, 5, 4, 8. What is my starting? This time I have increased my starting index to plus 1. So
Yes.
this is my starting index now.
Yes.
So what is my starting index here? What I will write? X, value of X is 4 and starting index is 1.
4.
1. 4 and 1.
1. Yes.
Same way, this time 1, 4,
5 and 2.
5, 4, 8. My starting index is, yeah, this is 4 and this is 2.
2.
Same thing, 1,
Yes.
4, 5, 4, 8. My starting index is 3,
4.
4, 3. Again, 1, 4, 5, 4, 8. List is also same. I'm not changing the list. Only what is happening? My index value in the same list is increasing. So
Yes.
this becomes 4, 4. This is 4, 4, 4, 4, 4, 4. Now, finally, what I will get? 1, 4, 5, 4, 8, and this become 4, 5. This is my index, starting index. Now, my L was, length of the list was 5.
5.
And finally here, by recursive calling of this function, my starting index has become also 5. Starting index become 5. So L Si is equal to L. Finally, this condition, I have met this condition. Is it fine? I have met this condition. Si is equal to 5.
L.
So finally, what will happen? This condition will become true. This condition will become true. And if this condition is true, what it shall return? -1.
-1.
So this thing is returning what? -1. Let's understand this in this way. This is returning what? -1. Because it has returned, so my iteration has stopped here. So sorry, my recursion has stopped here. My base case meet, my recursion is stopped, and this has returned -1 to this thing. Is everything clear here? Till here?
No. It has returned 1, so what is happening?
It has simply returned -1 to here. Now
Okay.
I am coming to the next part. It has simply returned because my condition is met here, and what this is saying, return -1. So it is returning -1 to the previous function call.
Okay.
It has returned -1 to here, to this thing.
Oh, okay.
Thereafter, now see, what is my next thing that it is asking? If a smaller list output is not equal to -1, return a smaller output. Fine. But here, my smaller list output is coming out to be -1. This is my smaller list output that I am returning. Na? This is my smaller list output. -1 is my smaller list output.
Yes.
And I am returning that smaller list output because I provided that condition.
Yeah, condition fulfilled.
Because this smaller list output is coming to be -1.
Yes.
See here what condition I have provided. If a smaller list output is not equal to -1, if it is not equal to -1, then return a smaller list output. But this is not a condition here. My condition is a smaller list output is equal to -1, opposite of this condition. So my control will move to the else block. If condition is not met, then where the control will go? Control will go to the next else block. So my condition has shifted here. My control has shifted here in the else because my smaller list output is -1. Now here, what it is asking in the when I am going to the else block, it is saying if A of Si is equal to X. What is A? A is this thing. This whole list is A. A of Si. What is my Si? 5.
Yes.
Starting index is 5 here. So what is my AI? 5.
Yes.
So if A of Si is equal to X, is A of Si is equal to X?
Yes.
No.
No.
What is my starting index? This A of Si is not equal to, A of Si is not equal to 4. So it is telling if A of Si is equal to X, if this condition is meeting, that means whatever is the starting index, if the starting index is the value of the starting index is equal to X, then return Si. Return that index. Otherwise, else what return? -1. So basically, it is happening like that. It has already returned this thing to here. Already it has returned -1. Now I am in this part. So it is checking if Si is equal to, so it is like, it is what it is checking? It is checking, is my starting index here, the starting index is 4.
4
So A of 4, what is the A of 4?
is
A
equal
of
to 4.
0, 1, 2, 3, 4. A of 4 is my 8.
Hmm.
This is my A of 4, na?
Hmm.
This is my A of 4.
Hmm.
So it is checking, is A of 4, matlab is 8 equal to my X. What is X? 4? No.
Hmm.
This
No.
condition is becoming false here.
Hmm.
So what? It is not going inside this. So else
Hmm.
what it will return? -1.
Hmm.
So it will return -1 to whom? To its previous function call.
Okay.
So it is returning -1 to this previous function call, because it is not meeting its condition.
Okay.
Fine. Again, what it
Yes.
is happening? Now see. Let me is these things from here. So let's, sorry. Now it has come here. What is my starting index here?
3.
3. Si is equal to 3. So it is checking here. Is Si is equal to 3. So what
Yes.
it will do? No, we have already reached here. So it is coming back. Now it is checking. Is a smaller list output is not equal to -3?
Yes.
Yes, my smaller list output is not equal to -3. Is not equal to
-1.
-1. Sorry, is not equal to -1. This condition is met.
Yes.
What it is telling? Return smaller list
Smaller.
is not equal to -1. So
Right.
what it will do?
It will go to else.
Else block. Now it is checking in the else block. What it is checking? A of Si. What is A of Si? Si is 3.
3.
What is A of 3?
4.
4. This is 4. A of 3 is
Yes.
4. This is A of 3 is 4. So this is 4. A of Si is equal to X. What is my X?
4.
4. So A of Si is equal to X. This becomes true.
Yes. True.
Here, this becomes true. If
Yes.
this becomes true, my control will go inside this loop, inside this block. So what it should
Return 3. Return
return Si. So what it
3.
will return? Return 3.
3.
So it will return 3 here. And we already have reached my condition. Now I do not need to, and it will return the same 3 here. It will return the same 3 to this. It will return the same 3 here. And finally, we will. So what exactly is happening here? And finally, we will get 3 as well. So what exactly is happening here in this code? Have you understood this thing?
Yes. Yeah. So that means, okay, if we have to find the last occurrence of X.
Last occurrence.
Okay.
So what I am doing, I am firstly reaching here. I am
Okay.
firstly reaching here, and then I am moving backward and checking my
Hmm.
condition.
Hmm.
This is what, through the recursive call I have reached here at the end, and from there I am started looking whichever is the first condition I am meeting. My first
Hmm.
condition Si, that my starting index is becoming equal to my x.
Suppose in the same case, if there is a question to find the index of first occurrence of x in a given, then what will be this thing?
So first occurrence we have already discussed.
Yes.
We have already discussed the first occurrence, how we will calculate the first occurrence. So you can
Yeah.
refer to that thing to understand how you can refer to the first occurrence.
Right. Right.
This is for the last occurrence. This
Last occurrence. Okay.
what is the last occurrence? So there is a difference in the code of those two. That's why
Yeah.
that was for the first occurrence. This is for the last occurrence. If
Last
there is,
occurrence.
if you have to find the last occurrence, so you can use this approach. And you
Right.
can even use a much easier approach, but I have already told you in the last class that since this is a little bit tedious to understand, so that's why I'm going to explain. Otherwise, what you can do, you can simply start from looking from this index value, and you should start moving backward. You will get it very easily. But this is a little bit proof. But here what I am doing, I am starting from this. I am starting from 0th index. Not I am starting. If you simply write your code in such a way that you are going to start from this index, this code will become much more simpler.
Got.
But what I am doing, I'm instead of I'm using that approach, I am using this a little tougher approach, so that it will be you can understand this approach also, and it will be better for you to understand different approach. So I have taken a little tougher approach.
Right.
This is how, because when we do the tough things, so easy things will become much more easier for us to do.
Exactly.
So have you understood this
Yes.
child code?
Yes. Understood.
Suppose if you have any issue with this code, you can discuss with me, and if you want, you can take different example and check this with the how the control is flowing, how we are doing. So first I've defined my base case here, thereafter, and it is not necessary that I shall start from 0th index as my starting index. I can take any index. Let's say I can take 1, I can take 2, I can take 3, I can take uh, 8. So usually we do not take 0 as my starting index, because let's say if my list is not empty, let's say if my list is empty, or if say list has only one element, let's say if my, why we do not usually take start from 0th index is one.
It's a better way to today it was better understood.
Yeah,
it's a better way of explanation.
yes. So see, why we are not using we usually do not take start from the, we do not take starting index is equal to 0, because let's say if this is a list, there is one list. So if you even start from zero thing, you will get, if the either if the list is empty, or if the list has only one element, let's say one element. In this case, if the list is empty, then the starting index will always, and last index will remain same. And if the index is only, if the list has only one value, otherwise, except these two conditions, if you take any list which has more than one element, let's say this list 3 4 3 9, let's say any list you will take, definitely if, let's say, starting index, if you get a value at your starting index x, if that condition is met, in spite of that, what you have to take, you have to take the value at the end index, at the end, but not this. But in this scenario, because in the previous case, so we have already taken that thing into consideration and code it in a way. We have taken this my base condition to be such that even we start from the 0th index or any other index, we finally have to start looking for the thing that we are looking from here only. So we will reach here, then we will start from backward. We will first check this thing, then check this thing, then test it. Whichever condition will met, let's say we have reached our condition here, this thing, and we will return it. So I suppose this is clear. Mr. Shankar sir.
Yes, yes, yes.
So shall we stop here? Fine.
Yes,
So this is the end of the recursion
yes,
with this question. Now we are
yes.
going to start a new topic, and that will be iterators and generators.
Okay.
So let me clear this screen and guys, thanks for coming, and you should keep watching the recorded sessions and try to come to the live classes and take the benefit. So stop here. I have to stop the